Hello, and welcome to this video on elastic potential energy for GCSE Physics and Combined Physics. And don't forget to like and subscribe. When an elastic object, like a spring, is stretched or compressed, work has been done on it to change its shape. Work done is equivalent to energy transferred, so energy has been transferred to the elastic potential store of the object. How much energy is transferred to the elastic potential store depends on how difficult it is to change the spring's length and how much the length has changed. When the spring is at its original uncompressed length, elastic potential energy is at zero. When the spring is fully compressed, the elastic potential energy store is at its maximum. The change in length of a spring is called the extension, even if the spring is compressed. It is calculated by finding the difference between the original length of the spring and the total length of the extended spring. The greater the extension, or compression, the more energy has been transferred to the elastic potential energy store. Here we have a spring with its original length at 4.6 centimetres. With masses attached, it is stretched to 8.2 centimetres, and that gives us an extension, our change between those two lengths, of 8.2 minus 4.6, which gives us an extension of 3.6 centimetres. Here we're compressing a spring. The original length is 8 centimetres, the total length with the masses is 4.5 centimetres, and the difference between the two gives us our extension, so 8 minus 4.5 gives us 3.5 centimetres. The stiffer the spring, the harder it is to change the length. The spring's stiffness is measured in newtons per kilogram and is called the spring constant. A large spring constant means more energy has to be transferred to the spring's elastic potential store to extend it by the same amount as a less stiff spring. This spring has a lower spring constant. It requires less work done to it to become fully compressed. The work is done by the masses losing gravitational potential energy as they lose height. This spring has a higher spring constant. It requires more work to be done for it to become fully compressed. Again, the work is done by the masses losing gravitational potential energy as they lose their height. As more work has been done, there is a greater amount of energy in the elastic potential energy store. As we have seen, elastic potential energy of an object depends on the object's spring constant and the extension or compression. The larger the spring constant, the more elastic potential energy is stored. The larger the spring constant, the stiffer the spring. And the greater the extension or compression, the more elastic potential energy is stored. The relationship between these variables is as follows. Elastic potential energy equals 0.5 times the spring constant times the extension squared. Or EE equals a half times K times E squared. The units, elastic potential energy, EE, in joules, spring constant K in newtons per metre, and extension E is in metres. In the next video, we will look at how to use this equation. And that's the end for this video. Thank you so much for listening.